Okay, I think it's time to begin. I want to welcome everybody to this webinar. Good morning, good afternoon, good evening, wherever you may be. This is how NFS latency undermines your competitiveness and what you can do about it. It's what I like to call the NAS performance blues. My name is Marc Staimer. I'm the President and Chief Dragon Slayer of Dragon Slayer Consulting. I've been a consultant for over 14 years now, 32 years in the industry. And I work with end users like yourself and vendors. End users like you don't pay me. Vendors do. I help them market more effectively. If you have a question, if you have a problem, if you're trying to solve something, anything in the data center, you're more than welcome to contact me. That's why you see my email and my phone number. I respond to every email and I return every phone call. Now before we get started, I want to talk about what we're going to cover today. We're going to talk about the NAS acute performance problem, bottlenecks with NAS, the workarounds and the pros and cons of each for those bottlenecks and the performance problems, and Alacritech solution. Now Doug's going to talk about Alacritech solution, and we're going to end up with some conclusions. I like to start every webinar and every presentation I give with a story. And sometimes the obvious is not so obvious. One day, these two storage administrators, they walk to work every day at the same time. And they meet up in front of the building about 10 minutes before 8, and they walk in together because they're really good friends. Well, on this day, one of them is waiting on the corner in front of the building just like he always is at 10 to 8, and his friend's not there. 5 minutes to 8, his friend's not there. 8 o'clock, his friend is not there. He's starting to get worried. He thinks something may have happened to his friend. A few minutes after 8, he sees his friend come riding up on this beautiful wooden bicycle. Incredibly gorgeous bike. He gets off the bike, says to his friend, okay, let's go in. His friend says, wait a minute. Where did you get this bike? He says, do I have a story to tell you? I was walking to work just like I always do. And I see this incredibly beautiful woman on this bike come riding by. She looks at me, stops, looks at me again, jumps off the bike, rips off all her clothes and says, take whatever you want. His friend nods sagely and says, good choice. The clothes probably wouldn't have fit. Sometimes the obvious is just not so obvious. So let's talk about the NAS acute performance problem. Basically, this shows up with your users, your clients, as increased response time on reads and writes. And typically the root cause is latency. Some people call it delay, but the technical term is latency. And that really leads to a lot of frustration and angst. It does reduce your productivity, and it can be especially vexing when it's intermittent. Now from a NAS admin perspective, I talk to lots of end users. And these are real quotes from admins, NAS admins. The users are going to complain until it's fixed. You know, that's common. And managers complain until the users stop complaining. The phones light up like a Christmas tree. And the vendors, they blame everyone else but themselves. Now, there are three typical primary root causes for NAS latency bottlenecks. NAS controller utilization, the hard disk drives, and NFS metadata handling. Now when we talk about the NAS controller utilization bottleneck, basically you got to remember that NAS is not just for serving up files anymore. It has a lot on its plate, like snapshot and snap rollback and mirroring and dedupe and thin provisioning and replication and virtual infrastructure integration and backup software integration and continuous data storage tiering, and RAID 6, and disk drive rebuilds, and bit scrubbing, and file serving. There's a lot it's got to do. And when it's doing all of it, it's not doing all of it well at the same time. In fact, when you're doing something like a RAID rebuild, a disk rebuild, you're going to suffer about 50% loss in performance on that storage controller, that NAS controller. And you get spiking controller utilization when all this goes on. And that will cause intermittent increasing latency and response times, which kind of makes those frustrations a little bit more on the user side. Now, the workaround for this, well, I'll just add more CPUs or cores or controller nodes. And that has some serious shortcomings. In economics, we call this the law of diminishing marginal returns. Each additional CPU or core or controller node adds a little less than the one you added before. And eventually, you add that one more, and performance actually decreases, not increases, which is why you see in scale-out NAS a limit on the number of nodes or controllers you can have. Because they know once you add one more, you get a decrease, not an increase. And ultimately, each one increases the cost of the IOPS. It increases the cost of the throughput and increases the cost of your total I/O. The next bottleneck are the hard disk drives. Now, everybody knows about the huge gap between hard disk drive performance and processing performance, and we all know about Moore's law at this point, unless you've been living under a rock. Basically, processing performance has been doubling every 18 months to 2 years. Great. That means in 40 years you've gone up 4 times, but between 2000 and 2020, that's 100 times per decade. 100 times between 2000 and 2010, and another 100 times by 2020. That's 10,000 times improvement. What if hard disk drives are going to do in that time? Stay flat. That's an increasing gap, and actually we could call it a canyon. It's getting bigger all the time. Now, there are a number of workarounds here. There's 6 that most people will utilize. First is they'll add more hard disk drives, or they'll do short stroking, or they'll do 100% flash solid-state drive-based NAS, or they'll do NAS with flash as cache, or they'll do NAS with flash SSDs utilized as tier 0, or they'll do PCIe flash cards, SSD cards, in the application servers. Each have their pros and cons. If you add more hard disk drives, the pros are it's simple. It's easy. You know how to do it. It's transparent to everything you're doing. Basically, it's no different than what you're doing now. You're just adding more hard disk drives. There's no rip out and replace, and you can get some really high density racks. Hey, you can get 60 hard disk drives in a 4U today. In fact, in one case, you can get 84 hard disk drives in a 5U. That's pretty high density. You can get as much in the 61, 240 terabytes. That's a lot of capacity in a very small space. And it will increase your IOPS and throughput most of the time. But there are cons. There's no free lunch in this world. For every positive, there's a negative. Now, the name of the game is you want to solve more problems than you create. Well, you're going to create some interesting problems this way. Basically, every NAS system has hard disk drive limits. You can only have so many that it will support. And ultimately, that means you have to add additional NAS systems, or you've got to replace it with bigger, more expensive NAS systems. And the thought is, well, hey, one's good, two's got to be better, right? What about 10, 20, 100? The reality is it's not a linear increase in management tasks as you add more systems. It's a geometric one. The reason it's geometric is you're not just doing the same tasks on different machines. Now you got more you got to do because you've added a lot more infrastructure. You got to manage that as well. In addition, think about the application that's writing to this NAS system and reading from this NAS system A. And now it's got to read from and write to B as well. How are you going to load balance that? Are you going to move data between them to make sure that you're getting equivalent performance? That's with 2. What I'm doing is a 3, 4, 5. It gets more and increasingly difficult. And if you go to the bigger, more expensive NAS systems, what you've created is a bigger bucket, but you haven't really solved the problem. You still got to do that. You just do it less frequently. So you end up with NAS sprawl. That's a big issue when you add more hard disk drives. And you end up with limited improvement as well. What about short stroking? DBAs, database administrators, have been doing this for years, right? The way to increase performance, I'm going to limit my data to the outer rim of the platter. And it does work. You're going to see latency reductions by as much as a third when you do this. And there's no upfront cost. Again, if you have extra capacity that you're not using, no additional cost. There's no rip out and replace. Pretty straightforward, and you're going to get better performance out of the drive. There's serious cons to this one because you're going to reduce the usable capacity of those drives by as much as 2/3 to 90%. One storage admin says, no, I don't do that. And I go, really, what do you do? He says, well, I short stroke, but on the inner part of the drive, the slower part of the drive, I put my passive data I don't access very often. I said, so what happens when you are accessing it, and then you've got to do a read or a write on the outer part of the RIM? He goes, well, then we sweep the disk. Yeah, you sweep the disk. And so that you can get higher disk failures, you can also end up with lower performance on that outer ring. It does waste capacity, and it doesn't save you a penny in power and cooling and space, or cables or conduits. And ultimately, it's a negligible benefit when the bottleneck is actually the NAS controller. This does require some real storage expertise to do. I don't recommend this to the novice. You really have to understand how to do this and how to troubleshoot it before you go this route. What about the latest stuff, the 100% flash SSD-based NAS? There's a lot of pros to this. It's going to be much better than HDD. You're going to eliminate the HDD latency because you have no HDDs. And it's going to really deliver a much, much higher IOPS, throughput, and lower response time. And it's going to leverage that SSD performance to provide inline deduping compression so you can get better usable capacity out of those SSDs. And candidly, the usable capacity cost today can be similar, not the same, but similar to systems with high-performance hard disk drives. That's pretty good. What are the cons? Well, there's no free lunch, and there are plenty of cons. It's a relatively new NAS system technology, and it does shift the bottleneck to the NAS controller. SSDs typically have much greater performance than hard disk drives, and the NAS controllers can't really utilize all of that. They can only typically utilize a small piece of that SSD performance. And one thing to be aware of, if you want this performance in more than one NAS system, if you want it not just in that one, but in the second one, you're going to have the same architecture in the second one as well. And you are going to have a higher overall total cost of ownership. Now, that tends to get reduced a little by the inline deduping compression. But ultimately, for a NAS system, it's going to be higher. One of the things this doesn't attack, which I'll talk to in a little bit, is the metadata IOPS, or NFS metadata ops within the NAS controller. And I'll talk to that in a bit. How about NAS with flash cache? This is a way to say, hey, I'm going to try to get the best out of the SSDs, but I'm going to take advantage of the cost aspect of the hard disk drives. So what I'm going to do is put the solid-state flash inside my controller, or as hard disk drive form factors behind the controller, and use it as cache, read cache. Not write cache, read cache. And it does improve IOPS, and it will improve throughput and response time, but it's an add-on to proven storage systems, meaning that the controller itself is not optimized in any way for solid state. So you're just taking up slots, whether PCIe slots or disk slots, to try to get the faster performance. And that's going to limit your performance gains. In addition, you're still going to have the NAS system as the bottleneck. And because it's caching, because it's not optimized for SSDs in any way, relatively speaking, what you're going to have is a limit on the amount of capacity you can use, which means as a cache, you're going to have more cache misses as the data sizes, as the file sizes increases, and they're going to continue to increase. And when you have that kind of misses, they're going to end up being shifted to the hard disk drive. So you're going to get intermittent performance issues once again. And once again, the cache in this system is not shareable as cache in another system. Alternatively, you can use those flash SSDs as tier 0. Now, in those systems where you're setting it up as tier 0, you can read and write to the SSDs. And so you're using it as not just a cache, but as a target storage. To do this, you also have to have software that will move that data from that tier 0 to the hard disk drives. And this can reduce some of your cost of ownership by allowing you to have higher capacity hard disk drives at lower performance and use the solid state for your performance. So you shift the passive data to the hard disk drive. Sounds great, and it will improve the IOPS to a point. The problem, once again, is this is improving in storage systems. You'll find, or in what's known as a hybrid storage system, what you'll find is that the storage controller really is not primarily optimized for solid state. And because it's not primarily optimized, you're going to get a limit on what you can get. You're going to have the NAS as your bottleneck once again, the controller itself as the bottleneck. And this software that does the automated tiering can be somewhat cost prohibitive and ends up taking away a lot of your savings that you would expect from going with a higher capacity hard disk drive and fewer of them. Total cost of ownership typically ends up being higher than most people expect. And once again, you can't share the tier 0 with any other storage system. Now, PCIe solid-state flash cards in the application servers has become very popular, especially in high-performance compute applications. It puts basically the higher performance SSD very, very close to the application. And it works in the server as DAS or cache. You're going to get your greatest IOPS, and you will, and the highest throughput and the fastest response time. But you're going to be limited. You're limited in the capacity you can use, the fact that many of these are server hogs. They're going to use as much as or more as 20% of the cycle. And when you talk about that, that reduces the number of applications or VMs you can run on that server. In addition, typically you're going to find that it requires software to move the data that's in the PCIe card out to shared storage in a virtualization environment. Because if you're not moving it outside in the server virtualization environment to shared storage, you're wasting your money because virtualization requires shared storage to do things such as, oh, I'll use VMware terms for right now, to do such things as vMotion, DRS, SRM, storage vMotion. Any of those advanced functionalities that you like, you need shared storage. So you got to have the caching software. The problem with caching software is there's only one that is designed for file caching software with NAS. It's called NEVEX. NEVEX was recently acquired by Intel. So you only have one provider who can do this. That's number one. And it's got to work with the cards that you want to use. That's number two. And you've got to have it running on every single server you have the card. Now this is going to measurably increase your NAS NFS metadata overall because you're going to significantly spike the NAS controller utilization between the caching software and the NAS controller. And one thing to be aware of, your total cost of ownership is going to be really high, and so is your labor intensiveness in this solution. You got to manage each and every server separately, each and every card separately. Now, one other factor, you can today actually share a card in one server with another server. You can do it over fiber channel with QLogic, or you can do it over fiber channel InfiniBand or Ethernet with Sambala. However, that's additional software, an additional management burden, in addition to what you're doing with the cards. And in the case of Q, it's a block-only implementation. In the case of Sambala today, it's only Microsoft. This is probably the worst bottleneck, the one that gets the least amount of airtime, because you can't really solve this just by slipping in SSDs into your NAS controller or putting in PCIe SSD cards inside your servers. It's the NFS metadata NAS performance tax, as I call it. You got to remember, NFS is a really chatty, stateless protocol. And basically, the clients and the server really need to exchange a lot of information for every single transaction. And you're talking about anywhere from hundreds to thousands to millions of round trips dealing with NFS metadata ops per second. And that's going to equate into as much as 80 to 90% of the NFS total. Wow, that's an awful lot of ops for doing nothing but communicate before you even do your transaction. And there's a lot that the clients have to know. Ultimately, this can overwhelm the NAS controller. This can cause a bottleneck in the NAS controller by itself. It's huge. Unfortunately, in the workarounds, there aren't any common workarounds except for Alacritech today. And they're about the only ones who are focused on dealing with this problem. So I'm going to summarize the NAS performance, and I'm going to turn it over to Doug after this, and he's going to tell you about Alacritech solutions. The root cause of all the NAS performance blues is latency. NAS controller utilization, hard disk drives, and the most powerful, the NFS metadata bottleneck. Common workarounds have devastating shortcomings. No workaround deals with serious NFS metadata problems. And there has to be a better way. Now to tell you about the better way, it will be Doug Rainbolt. Doug?
Thank you very much. Appreciate that. Over to my screen. Oh, sorry about that, guys. Jump forward here a little bit. I thought I had the slide deck at the right place. Let me just forward this down real quick. Apologize for that. Okay, here we go. Okay, well, good morning, good afternoon, wherever you're at. This is Doug Rainbolt, I'm the VP of Marketing with Alacritech. So first of all, who are we as a company? The company's been around for quite some time, since about 1997. It was founded by Larry Boucher, who's the second guy on your left here, the guy with the glasses there, looking pretty debonair and creative. He was the previous founder of both Auspex and Adaptech. He was the author of the SCSI standard. So it's safe to say that his knowledge base of storage and networking is quite deep. At Auspex, he had made some big inroads as far as performance and storage. And while there, he had this idea that perhaps more could be done around networking. They could see in a time frame, during the Auspex time frame, that TCP performance was really a bottleneck as far as CPU processor loads. And so we had this idea about making a special adapter that in essence would offload TCP processing for servers to enable better scaling. And so we left Auspex. That was his next mission, to build a company around TCP offload, which he did with Alacritech. We did well in terms of selling cards. We soon entered into a relationship with Microsoft. Most of you have heard of TCP offload from Microsoft called Chimney. We own much of those patents for that technology. And part of our relationship with Microsoft is to license other hardware vendors to take advantage of those patents around what we call stateful offload, partial offload to adapters. And from that point on, we licensed other parties, but then began to realize as time went on that we, as a company, in the adapter business, couldn't do as well as other people would, given their bent towards OEM relationships and their strength on that front, and plus the changing of the feature sets for adapter cards, moving away from just TCP offload to FCOE or to fiber channel or to iSCSI. The idea of unified storage extends as well to adapter cards. And so we thought, why don't we change our strategy and focus on systems, but at the same time have others be our proxy as far as vendors in the adapter world. So we've licensed people like Broadcom and Chelsio and Emulex to carry forth our technology into the marketplace. And we instead focused on building a system that really addressed a key pain point around storage acceleration, and primarily in NAS. So although we changed directions as far as a company, it really encompasses much of our legacy as a company of being both storage and networking experts. So our vision, our focus really is to be non-intrusive, to go into a NAS environment and be able to offer a very simple, pinpointed linchpin, if you will, that can have a lot of impact as far as benefits, but at the same time not cause too much disruption as far as current infrastructure. We're seeing the world change towards flash and new flash vendors and full NAS flash arrays and so on. And a lot of these vendors present something that sounds good, requires a complete wholesale change as far as infrastructure. And our view instead was, can we build something that enables people to realize acceleration of performance while keeping what they currently have as far as their infrastructure. So that was the idea, the vision for this new product. And we could see this this chronic problem exist everywhere, that people were faced with this idea of trying to scale NAS and to manage that scalability, trying to manage data growth, and being faced with data migrations and buying new NAS, and the symptom here oftentimes is NAS sprawl, having too many NAS devices in the data center, and not just being faced with the constraints as far as manageability from a people standpoint, but be constrained relative to space on the physical side plus power for these data centers. And scaling was painful to do, and so we thought, can we do something here to kind of reduce that pain and to stop the madness when it comes to scalability? So the answer for us and the cure for the NAS performance blues, as Mark alluded to, was the Alacritech ANS product. It's an appliance that is very easy to put into environments and to see benefits fairly quickly. What does it do in terms of quantifiable evidence that demonstrates performance? One is that it gives processor cycles back. As I said before, one of the key things we focused on in our TCP offload business was to really focus on giving processor cycles back to servers. And when you think about it, servers, our NAS boxes are servers too, and there's a lot of things going on as far as workload on these NAS servers. And the processor cycles are still fairly precious. And to be able to give those processor cycles back in a very non-disruptive way is really important, and that's what we do with this product. At the same time, we're able to help give usable capacity back to NAS, to make better use as far as efficiencies when it comes to the NAS deployment, making better advantage of the file system back end so that there's less wasted capacity on the back end. More of it's being used pretty handedly. The third thing is to really focus on the metadata piece, and as Mark said, that's a major problem for many customers, whether you know it or not, that the mix as far as metadata is quite substantial, maybe 80–90% of loads. We're seeing, for example, get attributes in some accounts that op-call be about 80%, if not more, in some user environments. So if we can do more to offload that, then that's a big win for us. So we introduced these benefits. At the same time, we're trying to find a way to get into the environments and have a very non-disruptive process that doesn't result in a lot of change for the customer. It plugs in, and you see the results very quickly. Now, how do we do it? How do we solve these problems? It goes back, first of all, to the technology that we've developed. We're in our 6th generation of ASIC technology. This basically is TCP in silicon. We took our 10 gigabit instantiation and modified that before launch to include just not the TCP offload, but to include optimizations for NFS handling as well as metadata processing. And what the results in as far as combination with our software value add, which is not in, which is huge as well, is great strides towards reducing latency. It goes down dramatically. So when you think about the appliance here, it's not storage, it's an acceleration appliance that uses cache, but its real focus is trying to move things out from the caches very quickly. And the latency is afforded not by so much the flash itself, but by the acceleration technology in our ASICs. That's where it really comes from. It's a transparent device as far as a NAS. It's a write-through appliance, which means we don't have a file system. We basically send traffic through as far as writes. We hold the write on the box until we get the ACK back, acknowledgement back from the controller, and then it's made available as far as caching locally. Okay, but these 3 things really make up the solution. Now back to the metadata thing, as I talked about, this is a major hit for a lot of environments. And as I said, I think we're seeing customers 80–90% metadata type loads can be huge as far as the traffic patterns. In a typical NAS environment, you might find for example, NetApp controller may max out around 500,000 operations a second as far as metadata. It is very CPU intensive. You have a lot of clients. These clients can number in the thousands that are doing get attributes and set attributes and just doing lookups and whatever that could consume a lot of cycles. And so the more that you're expecting from all these clients or the NAS to handle from all these clients, the worse your performance can be. And you start to see the processor bottleneck fairly quickly. we don't do 500,000. We can do about 2.7 million per second. And there really is a huge burden off these back ends. So below here, you can see in this diagram that if I can handle 90% of the traffic, it means that the back end sees a lot less as far as what it's focusing on. It's more on file updates and write optimization. I say we don't cache the writes right away. We wait for the act back, nor do we cache SIFT today as far as the appliance. But we do find that giving these cycles back to the NAS by handling about 90% of the traffic for the clients, that the controller in the back end has more cycles to engage in writes and more cycles to engage in SIFT's performance. They're both increased from a kind of a adjacent benefit. And I'll talk more in a few minutes about some real case studies that demonstrate that. So the paradigm change here for us and how we see it is that I think in the world of, I ride bikes a lot competitively, and I think about, you look at the Tour de France, you have domestiques and you have the killer cyclist, the Andy Schlecks and whoever, Bradley Wiggins. Those guys kind of lead the race, right? And the domestique's job is to take the burden off the rider, to give the water, to take the wind oftentimes. And that's our job. We don't hesitate in telling people that we are not the boss when it comes to NAS environments. The NAS vendors are. NetApp is king, Isilon's king. And so our job is to really offload those environments and to sit between the clients and the NAS, but to allow people to take advantage of all the tool sets they currently use as far as the NAS device. I'm not holding things back. As I said before, I don't have a file system, which means that back-end NAS is working as it should be working, and our job is to make sure it works really, really well. So the appliance sits in front of multiple NAS devices, not just multiple NAS devices from one vendor, but a lot of vendors. I support all kinds of vendors behind me, be it BlueArc, NetApp, Isilon sitting behind us. And so you're able then to amortize the benefits of this device appliance across a lot of clients and a lot of NAS behind you, and to, in essence, decrease the cache misses, and which can be fairly costly as far as the back ends, especially if customers are trying to, as one of their missions, to move more towards store media in the backside, like SATA drives, for example. So the cost for a write miss, the write penalty can be pretty high if you don't have a lot of cache hits. So this helps mitigate that point. Okay. And with that said, you can see the increase as far as utilization in the back end and a lot more performance. And all this without a lot of rip and replace. It's fairly simple, and there's no major updates required, as I've said 2 or 3 times. Okay, we're very focused as far as the markets. Any place where NFS is being used and there's a lot of reads going on, a lot of metadata requests going on, we can really help. Right? Some examples here, and this is not totally extensive. We have media entertainment, of course, oil and gas, things like travel timetables, life sciences, genome decoding, sequencing, and pharmaceuticals. Not to mention as well, we have software engineering and EDA are big markets for us as well. Those are key for us. Okay, so I'm going to share now, dig deep into some of the examples that we see. And for some of these, I can't share based upon NDA with the accounts, but I can give you a flavor of what they do. The next 2 slides I'm going to show you deal with a large software designer. They design software, and they actually make custom chips as well. This chart encompasses the very top. These are the words of the customer and what they could see as far as their quote. Below that, you see a line that says ANS stats, and this deals with all the NFS verbs and what happens as far as traffic. And this captures a point in time, about a week, going through the appliance. And what it's showing here is that there's about 10.4 billion operations that were offloaded from the NAS behind it. So if we're taking care of this traffic, the NAS behind us is not. So it's pretty important to see that we really took a huge load off that NAS. You can see the mix too as far as what's happening. You see get attrs here and lookups and accesses. It just bears out what I said before, that oftentimes the reads and writes, although really important, are dwarfed by the metadata. In this case here, the get attributes is a big % of the mix that this customer sees in their environment. Now you take a flip side. This actually is what the customer saw. So using the the operations manager from the NetApp environment, they could see this kind of reduction. So what you see in this chart in the very center, it demonstrates what happened from the NASA's perspective when we were in the data path. That the load went way down. We took on about 90% of the traffic coming through us as opposed to going to the back end, which had some huge benefits. Okay, the next slide I'll show you slides deals with one customer I can mention, and this has been publicized. In fact, the use case study is on our website if you'd like to view it. This deals with a firm called Rainmaker. Rainmaker is a post-production house, effects house up in Vancouver, British Columbia. And their problem was they had a rendering workflow, and they had a couple of Blue Arc Titan heads in their workflow. And you think of Blue Arc, you think these are pretty beefy controllers. They're used a lot in pretty data-intensive environments, especially HPC environments. And what they found was that with the two controllers that they were bottlenecked, that both CPUs on both Titans were CPU bound, nearly 89% CPU bound, getting close to 100% in some instances. And so they were on the verge of buying a third controller head. And these things are fairly expensive. I'm going to the price. You can check with the vendors there, but it's pretty expensive to put in. And if they put that in too, there soon we're going to be constrained too with a disk drive count in the back end. So the controller purchase would have been followed by a disk drive purchase fairly quickly. So they call us up and say, hey, we've heard good things about you from different studio admins in this marketplace. Would you mind loaning us one to test out? Which we do with vendors. We allow our customers, we allow them to test things out before they buy. And so they put the ANX up there, and when they did that, what was interesting to me was they took one controller off. So it went down from two controllers to one Blue Arc Titan controller. And they found that the traffic changed dramatically, that the ANX, for clients that were routed through the appliance, that we could, much like the previous slides for the other account, absorb about 90% of the traffic. Okay. And so when you count two for the total traffic, there were some clients that went around us to the storage. But when you factor in everything as far as clients coming through us and around us, that they could see a reduction in latency, about 80% across all the operations for all the clients, which is significant. This chart basically just depicts what they could see then relative to the data flows every day. So they were seeing about 7 terabytes of NFS data coming through the appliance every day, and they saw a peak about 27 terabytes on one day. And during a 5-week period, they recorded about 98 billion operations being passed through the appliance. So it's quite significant. Now, the real thing that I liked in terms of what this meant for them is they found that by doing this, they were able to decrease the CPU load on that back end. And that CPU load, again, was spiked based upon requests, which included a lot of get attribute requests on this thing. But they could see the CPU utilization drop from 100% to about 60%. Okay. And with the two they currently had, so they could bypass buying that third controller for quite some time. So there is some savings here relative to the management side as far as configuration for the third head. There's savings relative to buying the controller, and certainly savings relative to the power differential between buying Alacritech and buying a new node, a new Titan head. And the disk drives as well behind that would have been required, which I mentioned. So a lot of savings there right away. And they found that the traffic decreased by 35% going to the NAS itself. A lot of headroom here. And they found too as well that the operations as far as disk operations decreased from 160K to 70K. So on average, which was a big drop for them. So again, some huge savings here in terms of performance increase as well as a decrease in terms of cost, both CapEx and OpEx. So you get this kind of double bammy, as I think of it. You get the benefit relative to a opportunity to increase revenue, which these guys do. Jobs get done faster. You get better goodwill with your customers, better customer satisfaction. At the same time, you're leveraging what you currently have as far as NAS infrastructure with a small linchpin change that huge leverage benefits. So a cost reduction as far as infrastructure, as well as a performance boost that resulted in perhaps revenue increase, which increases bottom line pretty handsomely. What we find as a company that a lot of times, and this is new for me, really given my background, I'm used to dealing with a lot of storage admins and CIOs, but we find a lot of people coming to us are not in the IT team, but actually the user team, who are the application owners, and their request of us is to help with application acceleration. And we're seeing that more and more, and so the audiences we now address, and you might be there too as far as who you are, is around how do you help me get these applications go faster so I can decrease my latency and increase my customer satisfaction, increase path of possible revenue, and help my IT team. So oftentimes we're introduced by people from the user group to the IT team. So one of the questions that came up on the list here, I could see it, was do we work with other vendors? Do we work with who are they? Yes, it's all the NAS v3 vendors. So it's NAS, it supports NFS v3, we can support it. Be it NAP, all the the FAS 2000, 3000, 6000, Isilons support that as well, and even the EMC VNX, HP as well. BlueArc I mentioned too, we support that as well. It all works. All right, so kind of summarizing here, and we'll have time for questions too, more questions, is that, again, our focus really was to leverage on solving a real performance problem and to focus on a problem that we could do so in a very non-intrusive way. And one of the root causes we see in terms of these problems is latency and metadata. And they go hand in hand. And these two things could have huge impacts as far as performance. And oftentimes they go unnoticed by admins. They sometimes get used to the status quo of adding more NAS to their environments and don't have the option of stepping back and saying, is there a better way to do this? Can I get more from what I have and still decrease my latency, increase performance for users, and bypass buying more? There's offerings out there in the market. There's quite a few, but quite a few are disruptive as far as what they do. And we don't think they really handle the metadata problem like we can do. Again, the acceleration technology really helps address that squarely. We focus on the root problems, we address it, and again, this is not storage. It's simply an acceleration appliance that does cache, but the more important thing is it accelerates with anger. Just moves data quickly across the network and accelerates your applications. That's the bottom line. So as far as another question came in is what does it cost? There's two versions of this current product. We have more being planned for next year. I can't talk about that at this point. But the ANX, there's the ANX 1500-10 and -20. The 10 incorporates 10 SSDs. Each one is 200 gigabytes for a total of 2 terabytes in storage. It lists at $83,000. Okay. And the other one is the 10 or the -20, which contains 20 drives for 4 terabytes. It lists for $134,000. That's list price. So 134, and you look at that and say, "Gosh, is that worth it?" Well, look at the if you have time, look at the spec.org chart and look at the performance numbers from a cost per op standpoint. You'll find that this is pretty reasonable, like 1/3 of what our competitor is as far as cost per op. And because of all this acceleration technology. So during the benchmarks, you go to spec.org, you can see us showing 120,000 NFS operations based on the mix with 134K list box with the lowest latency recorded of any submission, which is 0.92 milliseconds, which was pretty remarkable, we think. And the bottleneck on this, by the way, in terms of the performance was not the ANX. It was the back end in terms of disk drive count we had to deal with. We found those testing too that we compared what we did with an older 6070 from NetApp with a brand new 6080 in that time frame. And we achieved similar throughput, but the latency was half. And we achieved half the latency and the same throughput with half the disk drives. And when you cost this out relative to the disk drive enclosures and the power that goes with that, it was a huge savings. Okay, another question I received is, how does it work better than the cache and the NAS controller? It's a good question. I'll answer this in two parts. The first thing is this. It goes back to what Mark talked about relative to these NAS controllers. More is being asked for them, not less. It's a server. Okay, it's doing all kinds of work. And there's all kinds of stack routines and calls. There's a lot of times latency in terms of the multi-threaded nature of controllers, if you will. And so I compare it to like a Ferrari at a stoplight, right? If the controller's bottleneck is transferred to the CPUs, and the CPUs are nearly 90%, it means that you can't harness the IO potential, the NFS operation potential, both from the controller. And so what we did was build an appliance that really is unencumbered with all those headaches in terms of the I/O and the processor load, and of a sample or cycles to spare. So one of the major differences here between cache and the server is we store it. It can be shared across a number of NAS devices. That's really important, across a number of heterogeneous NAS devices. And plus, from a performance standpoint, you can't touch the latency. No one comes close to what we can do as far as latency reduction for the reasons I mentioned. I should have added too, when back in the spec runs we did, the CPU, when we tapped out, was only 15% utilized at that point. Let's see, more questions. A question, does it work in virtualized environments? Yes, it does. We're going through a lot more rigorous testing now as far as VDI, and I hope to have some VDI testing back as far as some collateral soon. So the question was not about server per se, or it was server. I'm going, yes, we do work in server environments, and we are making strides to validating and displaying results as far as VDI. Oh, question about, can I have more than one in my environment? Absolutely. You're able then to fairly easily use more than one and to mount different file systems, so you can use them that way. At the same time, people who want availability can have a active-passive type configuration, having two, one being active, one being passive, where the passive absorbs all the configuration files, and upon a failover, it will assume control of all the connections. But we'll be announcing fairly soon plans for N+1 active-passive, N+1 with N being 3. Stay tuned for that. Oh, a question came through, which is fairly common. I probably should address this. People ask me quite a bit, what's the difference, or how is Alacritech alike or not alike of Veer systems? Both companies are really geared towards supporting NAS environments and adding a performance layer, if you will. But a Veer, from our perspective, is a storage vendor. It's a tiered storage vendor. It contains a file system that's really geared towards providing fast tiers of media in environments that could use it, and being able to support that. They do really well, for example, in wide area networks, where they're going to be able to support remote users and pass things back, given the write-back model, how they work. But it really is a NAS device, and much of their collateral these days addresses that they are a NAS edge filer, if you will. We're not that. We're not storage. We simply sit behind the storage or beside the storage you currently have, and our job is simply to accelerate what you currently have as far as NAS devices. We don't store. We cache and accelerate. That's the major difference. And our view is to safeguard and protect the assets you have and not interfere with the tool sets. There is consistency between the back end and what's in our box. That was our design goal from day one. Okay?
Are there any other questions? Doug, thanks for explaining the ANX.
My pleasure.
Everybody, thank you for attending. We appreciate your time, and hopefully we've answered all your questions. If not, please contact Doug at Alacritech, and thank you for coming again. Have a great day.
Thanks so much. Take care.